All right, guys. So this is number 7, example 7. If you look, Mr. Cohen and Mr. Marr are on a road trip together. Mr. Cohen drives 60 miles an hour while delivering a package to a customer. On the return trip, Mr. Marr drives on average 50 miles per hour due to construction. All right? Total driving time is 6.6 hours. Our goal is to determine how long does it take for each trip. All right, so we're going to need some prior knowledge for this one. So what we do recall from the other sections is we know the formula distance equals speed times time. All right, that's something that we know already, that we've done many times, so we have that. All right. In the last section, we talked about solving for other bits of information. All right, the literal expressions. Can we solve for speed? Can we solve for time? All right? We know that this one here is for distance. Can we come up with a new formula for speed? Or rearrange the formula that we already have so we can solve for speed? Which all we're doing is to isolate our S variable. So very easily, we can determine that we can reduce out our time, and we know that speed equals distance over time. So we now have one equation, two equations, and we can do the same exact type of work to determine what the formula or the equation for time is. All right? We can do the same things for time. All we're doing is taking distance equals speed times time, dividing out our s's. We're moving our speed to the other side to determine our relationship with time. So we can conclude that time equals distance over speed. If you look at those three equations, they are all exactly the same. They represent the same material. It's just solving for a different variable. All right, that's very important to what we're going to need to solve the remainder of this problem. All right, so let's break down each piece. Let's make a column for Mr. Cohen. And let's label what we know for him. All right, we know Mr. Cohen's speed is 60 miles per hour. We know that his time is unknown. We know that his distance is also unknown. All right, so there's a couple things that we don't know yet, but we'll get there. For Mr. Marr, similarly, we know that his speed is 50 miles an hour. We don't know time as an individual trip, and we don't know the distance. So we have too many unknowns to just choose one of these equations to solve for our unknown variable. All right? But using a little bit of logic, what do we know about the total time? We know that the total time is 6.6 hours. So we can take the time of Mr. Cohen plus the time of Mr. Marr and have that equal the time of our total. All right? We know that Cohen's time plus Mr. Marr's time is equal to the total time, which we already know that the total time is equal to 6.6 hours. All right, but we still have two unknowns. We don't know what Mr. Cohen's time is, and we don't know what Mr. Marr's time is. Now some of you are probably thinking the time for each one is 3.3, right? Half going there, half coming back. But why can't we conclude that? Because what do we notice about their speeds? Their speeds are not constant. So the speed is very important to understand that the times are not equal. But if we use this handy little equation right here, we could replace some of our unknowns with some known pieces of information, or substitute in an equation we already know. Mr. Cohen's time is equal to the distance, which is still unknown, over his speed. All right, the distance of Mr. Cohen over his speed. Mr. Marr's time is equal to the distance of Mr. Marr over the speed of Mr. Marr. And we still know that it's 6.6. What we can then conclude is we know their speeds. So we can type our distance over 60 plus our distance over 50 is going to equal 6.6. Now, what do we know about the distance? We talked about this in past problems as well. The distance going somewhere and the distance coming back on that same path is going to make these two distances the same. So right now we're left with two fractions. I know you guys are freaking out that there's fractions in a problem, but how do we solve, or how do we combine terms or use addition with fractions? We have to find our least common denominator. The least common denominator between 60 and 50 is 300. So we can find our least common denominator by multiplying this by 5 and multiplying this by 6. So we can say that 5d over 300 is plus 6d over 300 is equal to 6.6. Using a little bit of algebra, we can conclude that 11d over 300 equals 6.6. We just combine our terms, right? I'm just going to drag this up to the top. We can now say 11d over 300 is equal to 6.6. And once we have that, we can start to eliminate some of our coefficients on the left side. Right? By using the inverse of dividing by 300, we can see that 11d equals 1980. And we don't want 11d, we want just d. So we can conclude that our distance equals 180 miles. So it's 180 miles there and 180 miles back. So we can start to conclude that we have 180 miles going and coming. Now that's not the question. We're not done, right? We didn't do step 4, we didn't look back. The question states, how long does it take for each trip? All right? Luckily, we could check this. We could check it. Distance is equal to speed times time. Or time is equal to distance divided by speed. So time for Mr. Cohen is equal to 180 over 60. Or Mr. Cohen's time is equal to 3 hours. Now we could try to use this the same way and say that this time for Mr. Marr is equal to 180 miles over 50 miles per hour, right? This is miles per hour. And we can conclude that Mr. Marr took a total of 3.3 hours. Now, how do we know that we got this correct? Because our total time should be what? 3 hours plus 3.3, I'm sorry, this is 3.6. All right, that's 3.6. You can correct me if I'm wrong. All right, and that would give us a total of 6.6 hours total. All right, so using these pieces of information, we can answer how long does each trip take. We can say that Mr. Cohen takes 3 hours and Mr. Marr takes 3.6 hours. All right, so I hope that helped, guys. All right, there's gonna be 2 problems posted on Google